Hello everybody, my name is Jessica and today for this presentation I'm going to be talking a little bit about hydrophobic versus hydrophilic. What does that mean? What characteristics do they both possess that make them separate from each other, as well as some examples to give you kind of a real life look at what these substances look like. Now if we start from the very beginning, hydrophobic. Hydrophobic, the last term phobic is a pretty common term that a lot of people know. Generally it's, we think of people with phobias, arachnophobia, water phobias, all that, something that we fear. So with hydrophobic, it's basically water fearing. This substance does not dissolve in water. It is non-soluble. And the reason for that being is because hydrophobic substances they have nonpolar compounds. So they only attract to neutral molecules. And water, being a polar compound, being essentially the polar opposite of the hydrophobic molecule, they repel each other, kind of like magnets. Magnets, if you put them backwards together, you won't be able to get them to connect, which is the exact same thing as a hydrophobic substance. And if you look at everyday examples, you would think of a lot of fabrics, couches, blankets, they're all water resistant. And a lot of that means that they are coated with a substance that is hydrophobic, that repels water, that kind of keeps water from saturating the fabric, essentially. And a lot of people think of any kind of oils, cooking oils, gas, oil, any kind of oils. All of the oils repel. They do not dissolve in water, and they are not water. They are hydrophobic molecules. Now for hydrophilic, it's the exact opposite. They are water loving. They are completely soluble in water, and the reason that they are soluble in water is a hydrophilic substance has ionic and polar compounds. Water, like I said before, has polar compounds, so they both can come together pretty well and dissolve together, and that's the characteristics that you would look for. Is they both have this polar compound that kind of connects the two and makes it easier to dissolve. Now the best example that I have for the hydrophilic, and the easiest that a lot of people know, is drinking coffee in the morning. If somebody were to take their coffee and go and grab their sugar or glucose and put it in the coffee, what would happen? Well, the sugar would dissolve. And why is that? Because sugar or glucose is a hydrophilic compound, which means it can dissolve in water, and then they form together. And the only other one that I have is aluminum foil. Aluminum foil actually repels water, which is something that I actually learned the other day. I mean, it makes sense, but it's still something a little different. And basically, hydrophobic and hydrophilic, opposites of each other. They both want, if you think of a phobia, you can relate to hydrophobic, which means water fearing. If you think hydrophilic, you're thinking of loving, water loving, which is the easiest way to discern from the two. Also, remember that if you're looking for a substance to be either hydrophobic or hydrophilic, you're going to want to make sure that those polar compounds are either present or they're non-polar. That'll give you the best chance of figuring out the substance was hydrophobic or hydrophilic. Thank you.